Welcome to this presentation on modular test, PXI as a standard versus proprietary modular systems, sponsored by the PXI Systems Alliance and Pickering Interfaces. Hello, my name is Bob Stasonis. I'm a technical product specialist with Pickering Interfaces and a member of the board of directors of the PXI Systems Alliance, or PXISA. Now, the term modular testing platform has been synonymous with PXI over the last 15 to 20 years. But I've heard from relatively new test engineers that they're not totally clear on what modular means. This term is used by many test companies, and in most cases, has the same meaning as PXI. That's because PXI is a standard that embraces the concept of modular test. The term module is defined by Wikipedia as a design principle that subdivides a system into smaller parts called modules, which can be independently created, modified, replaced, or exchanged with other models or between different systems. This term is applied to modular homes, modular furniture, and very many other modular things. But here we're focused on test. In this short presentation, we'll categorize the differences between a modular standard and a proprietary modular system. Industry standard platforms like PXI use modules from many vendors supporting the standard and can reside in a single chassis made by any of the vendors that make PXI products, compared to proprietary platforms where the mainframe is restricted to strictly modules from that company's supplier. They're very different in terms of mechanical form factor, but both are very good solutions for tests, and they can work independently or work together depending on the application. Now, before we set definitions, let's be sure we're all on the same page. In this presentation, I'm talking about electrical functional test, or FCT. Basically, we're testing a printed circuit board called a PCB, or a subsystem like a field replaceable unit, or FRU, in an aircraft. FCT is typically performed during the last phase of the production cycle. The goal is to create an environment that provides signals and makes measurements from the connectors that simulates the system that PCB or FRU works in. The advantage here is that we're testing the unit as a whole, just as it would operate in the real world, and can verify firmware in known good and known bad situations. In virtually every case, the test system will integrate power supplies, instruments, switching, electrical interfaces, and software that operates the tests, makes appropriate measurements, and determines the pass-fail status of the unit. Now, like anything, instruments being used in tests have evolved over the last, say, almost 100 years of electronics manufacturing. Early instruments, like you see in the upper right-hand corner, I'll call them old school, for lack of a better definition, are single-function standalone devices. They each have their own power source, front panel control with switches and knobs and meters and so on, and often some communication protocol like GPIB, which is a parallel bus communication standard introduced in the mid-70s and still in use today. In the past, programming commands tended to be proprietary, so if you had multiple vendors, the programming formats of each language is slightly different possibly. When you use a bunch of these instruments together, it can be very expensive, complex to cable, and as you can see here, rather large. In the late 80s, test measurement companies banded together to address the size, cost, and add features that make test engineers' jobs easier. Modular, as it applies to test systems, was first applied in 1987 when the VXI, or VME Bus Extensions for Instrumentation Consortium, started in 1987. The companies like Hewlett-Packard, Colorado Data Systems, Tektronix, and many more formed a consortium to take the existing VME bus modules and create a standard for test and measurement companies. The VME bus by then was about 6 years old and used by many companies, so it was stable and reliable. People knew it. But the companies I mentioned earlier wanted to add features that all test and measurement companies utilize. Those include standardized instrumentation synchronization and trigger buses. So in 1995, VXI 1.0 was released. VXI was the first standard to design instruments with no front panel controls, just connectors, no switches, no knobs, nothing. Software had advanced to the point that the operation could all be done from the controlling computer. Modular also meant that all stimulus and measure instruments are plugged into a common chassis, providing power, backplane control signals, synchronization, and trigger buses. This design helped to produce smaller test systems as you no longer needed so many rack-mounted instruments. In the bottom right corner of the slide here, you see a VXI chassis full of instrumentation. The military and prime contractors of branches of the military seized on this whole form factor and adopted it worldwide. It was a de facto standard for manufacturing and depot repairs in the 90s and early 2000s. Now, also in the mid-1990s, National Instruments took a closer look at VXI and decided they could create a standard that would be smaller, faster, and lower cost than VXI. So National Instruments took the PCI, which was the computer bus standard for millions of PCs at the time, adopted the compact PCI form factor, and added the features of a test that would put in VXI. So in 1997, they launched PXI, which means PCI extension for instrumentation. In 1998, they partnered with other test and measurement companies and launched an independent organization called the PXI Systems Alliance, or PXISA. The formation of the alliance made PXI an open standard. Any company could create PXI chassis and modules as long as they join the alliance and adhere to the specifications. In turn, the PXISA committed to promote and evolve the standard as technology required, but also ensure backward compatibility to earlier modules as necessary. Today, there are more than 60 members and thousands of chassis, instruments, switching, and mass interconnect. To help companies cope with the issue of building their own test systems, there are many system integrators worldwide, large and small, to assist in your system integration. This is important if you either don't have the capacity to build it yourself, you don't have the expertise, and you just need extra support, and they're available. They're out there. One of the strategies to help keep PXI relevant is that it's based on other standards. For communication, the PCI and PCI Express buses are used in millions and millions of PCs, and the mechanical form of compact PCI can be seen in telecom, automation, embedded solutions. These two standards are upgraded by their own consortiums as technology changes, and PXI works with them to ensure that the evolution of this product makes systems faster and more relevant to new technology being tested. The concept of triggering, synchronization, and system expansion have evolved with the PXI standard as well. Now, this slide shows the basic architecture of PXI. For simplicity, I'm just showing PXI, but PXI Express works on a similar architecture. Like any desktop PC or laptop, you have a motherboard with a CPU, controller, memory, and peripherals. In the case of PXI and PXI Express, the backplane has more peripheral slots, and the CPU and memory controller are modular as well. In this way, you select the best controller for the application, or use an external PC to control the PXI chassis and other peripherals that just don't fit conveniently into the PXI chassis. There are several remote control systems from several members of PXISA that makes this job easy and transparent. There's two physical size PXI modules as seen here. The 3U size is the most popular, but 6U is found a niche in defense and other related applications, including portable test systems where small size with maximum capability is most important. Note the difference in the connectors of the 3U PXI Express module. The XJ4 top connector is not compatible with J2 on a PXI1 module. PXI1 is the description of the original specification. We'll discuss more about PXI Express in a moment. An important thing to keep in mind that in many applications, you just might not be able to pack everything you want into a PXI chassis. Devices like high current power supplies, test loads, certain vertically integrated standalone instruments, and a lot of high I/O requirements that are not easily satisfied in this form factor. So when you design a system, pick your test components based on the specifications you have to test to, availability in what form factor, and your test budget. Of course, many requirements will be satisfied by integrating PXI and PXIe. The good news that test and programming software like C++, LabVIEW, and ATeasy have created environments where all these components play nice together. The bottom line for the test engineer is that PXI will give you a compact test system that is tightly integrated and will work with all of your big stuff. Now let's compare the two sides of the standard. PXI has a parallel bus, 32 megabit, 133 megabit per second communication between the PXI modules. This was more than adequate in the 90s for a large portion of applications that PXI could address. But today we have applications like 5G, Wi-Fi, and other high-speed serial networks. So now we need to support gigs of data. So in 2006, PXISA released PXI Express 1.0. Instead of a parallel bus, we have a point-to-point high-speed serial bus with multiple connections called lanes. Now, each lane on its own is faster than PXI1, but multiple lanes can be aggregated to get even higher data rates. For example, a third-generation PXI Express chassis can manage up to 24 gigs per second on a single instrument. This is used by many high-speed data modules, as well as complex waveform generators and high-speed digital I/O. Now, remember, legacy modules may not benefit from the speed of PXIe, so some of the members may be slow to migrate to PXIe. Plus, there's also legacy modules you'll be using in other test systems. Fortunately, the PXISA specified hybrid slots that accept both PXI and PXI Express modules in the same chassis. So if you're designing a system that uses both PXI and PXIe, make sure the chassis you select has adequate hybrid slots. Over the past 25 years, the PXI standard has seen worldwide acceptance in many applications. In this slide, you see the predicted growth through 2025, courtesy of Frost & Sullivan. Applications from semiconductor tests through 5G telephony and autonomous vehicles are being tested using the PXI standard. Back in 2017, NI announced there was over 100,000 PXI-based test systems in operation worldwide. And over the last 6 years, we've added many more PXI test systems. So clearly, this standard is almost ubiquitous in the test world. If you want to learn more about PXI, go to the Alliance's website, www.pxisa.org. There you can download specifications, review the members of the Alliance, and see what modules are available to address your testing needs. Now, I said earlier we talk about modular when it's a standard and when it's not a standard. Many test and measurement companies have created modular solutions that fit a particular application and does it well. A few examples are seen here in this slide. There's times when applications like switching and select instrumentation need more connector space or more PCB real estate for the functionality of the components. The key to keep in mind as you design a system, I said, your system component selection can be based on specifications, availability, form factor, and your best budget. These guys all play nice together because the software drivers are compatible. So choose the right instrument, the right switching that fits your test needs. So in conclusion, the term modular has a long history in test and measurement. And based on PXI market forecasts, modular test is here to stay. But remember, all modular is not mechanically compliant. Only a modular standard guarantees multi-vendor operability. PXI has been evolving for more than 25 years, addressing more and more complex applications. Works with other standards, and many vendors not only create PXI modules, but other support components. PXI and other vendors' components help you create a very complete and comprehensive test solution. Finally, Pickering Interfaces has a book called The PXImate. It's a non-commercial overview of the specifications and some of the things to know when integrating PXI. The PXImate is about to release its 6th edition, so that document is being relevant to the latest releases. Pickering has cooperated with PXISA to let you download a PDF or request a hard copy. The links you may need are included in the PXISA newsletter. Thank you again for your time. Have a good day.